All right, we're going to move on. We're going to move on to the second category of word problem, which is the interest problem. Now, we've already done the interest problem back in Chapter 3, but in Chapter 3, we had a relationship given to us between the two unknowns. On number 3 for this interest problem, you're going to see we're going to be getting a total. So here's how it reads. You inherited $5,000 with the stipulation that for the first year, the money had to be invested in 2 mutual funds paying 9% and 11% annual simple interest. How much did you invest at each rate if the total interest earned for the year was $487? Notice, people, the two unknowns, how much did you invest at each rate? How much was invested at 9%? How much was invested at 11%? They gave us no information about either one. The only thing that they told us is that the person inherited a total of $5,000. And the stipulation was some of that $5,000 had to go into a 9% mutual fund, and the remainder had to go into 11%. But we don't know anything about either 9% or 11%. So this is best solved by utilizing a system. And we're going to move to it right away because you're going to find out that this problem is no different than roses and carnations and adult and children tickets at Superman. It's going to be the same idea. So let's move over to the whiteboard, and here we go. Step number 1. The question is asking us to find, what is the amount? What is the principal? What is the amount of money that's going to be invested at each rate? 9% and 11%. That's what it's asking for. The column, you're aware of it. Principal times rate times time, interest. The title of the rows. One of the accounts, 9%. The second account, 11. They can be interchanged. Look at the word on the bottom row. Just like roses and carnations, just like Superman. Total. Let's begin to fill it in. How much money is going to be invested in 9%? We don't know. We're going to give it a letter. And in this case, we'll give it X. How much principal, how much money is going to be invested 11? We don't know. We'll give it Y. But we do know the total principal, the total amount of the investment. That was $5,000. Folks, roses, carnations, 20. Adult, children, 800. Amount of the 9% investment, 11% total. Now key, the interest rates. Here's our 2 rates. You must change those rates to decimals. To change those rates to decimals, you need to take the decimal points and move them 2 to the left. So I'll do it here. There's the point on the 9. There's the point on the 11. To make it a decimal, you got to go 2 to the left. This is key. 1, 2. You're going to have to prefix a 0. 2 to the left. Free spot, nothing. The time, only going to be held in account. The stipulation was from the person that gave the inheritance, you had to keep the money in the account for a year. 1, 1, nothing. Okay, let's write down the amount of interest that the people are going to be earning from the 9% account. Principal times rate times time. 0.09 times 1.09 times x, 0.09x. 0.11y. Okay. The amount, this is the interest column, the total amount of interest that the person that's getting the inheritance is going to receive at the end of a year. I believe it said it was $487. So you want to write it as this. Put the point and put 2 zeros. There's equation 1. There's equation 2. Why? The amount invested at 9 plus the amount invested at 11 better total 5,000. That is a truth. The amount of interest earned off of the 9 plus the amount of interest earned off of the 11 will equal the total amount of interest earned off of both. Now, just like we did on the roses and carnations and the adult and children tickets for Superman, move those decimal points over right now. Get rid of them. Twice to the right, twice to the right, twice to the right. Here we go. Equation number 1. X plus y is equal to 5,000. That's number 1. Equation 2, column 3, 9x plus 11y is equal to 48,700. There's number 2. Now, just based on the size of those numbers right there, people, I think I'm going to use elimination. If you want to use substitution, you would take equation number 1 and bring it over here and either solve it for x or y and then substitute that into number 2. I'm going to use elimination. We have to find the amount invested in both so it doesn't make any difference which letter you get rid of. Coefficient is 1. Coefficient is 9. LCD is 9. LCD is 11. I'm going to get rid of the x. He's right in front. Tuck. Tuck. He's a positive 9x. I want to make him become a negative 9x. Negative 9 on the left, negative 9 on the right. Leave him right there. Let's distribute. Negative 9x, negative 9y is equal to a negative 45,000. Draw the line, add down. Goodbye. 11y, negative 9y. 2y is equal to 3,700. Over 2. Over 2. Y would be equal to, I believe it would be $1,850. Put at, now we got to know what percent it's going into. Y. Y. 11. Circle. And go ahead and put the x right there, get it ready. And now we need to find the value of x. Pick either equation number 1 or equation number 2. The clear better choice is number 1, the original number 1. X plus y is equal to 5,000. We have the value of y is 1850, plug that in place of y. X plus 1850 is equal to 5,000, negative 1850, negative 1850. I believe if I'm doing the subtraction right, without doing and showing any, well, I'll show it. You got a 0, you borrow. You can't subtract 5 from 0, so instead of borrowing from 5, I'm going to borrow from 50. And you borrow 1 from 50, and you're going to be left with 49. Make him a 10. 5, 1, 3. $3,150 $50 at 9%. Those are the two principal amounts that the money is going to be invested at. That amount at 11, that amount at 9, it certainly satisfies the question up there. Now that's the interest problem. I'm only doing one of them because we've really already done an interest problem before. So I'll turn away from that. And now I want to get the mixture problem out of the way. Now we're going to do two of them. The mixture problem is somewhat of a more unique kind of a problem. One particular reason why the mixture problem can sometimes cause concerns, if a student lets it cause a concern, are all of the percents that they see in the problem, all of the chemical names that they see in the problem, and labels that are in the problem. If you let it be overwhelming, it will be. But we're not going to let it be overwhelming. We're going to give you some guidance so that we can handle the mixture problem. Now I want to read number 4 first, and then I want to talk to you for a bit as we move into this problem. A chemist working on a flu vaccine. Interesting question based on what we're going through currently in the United States. A chemist working on a flu vaccine needs to mix a 10% sodium iodine solution with a 60% sodium iodine solution to obtain a total of 50 milliliters of a 30% sodium iodine solution. How many milliliters of the 10% solution and of the 60% solution should be mixed? Now, let me kind of give you a background somewhat of this, of a problem that is dealing with mixture. I'll make it pertain to the one that we just read. The chemist in this problem is in need of a 30% sodium iodine solution. That's what he needs to obtain. When he goes back to his lab, he's looking on the shelf where all of the sodium iodine is labeled. And unfortunately, he doesn't find a container that is labeled what he needs. He doesn't find a container that is labeled 30% sodium iodine, but he needs 30%. 31 won't do, 35 won't do. He needs a 30% sodium iodine solution to contribute to this vaccine, but he doesn't have it. So he has to derive it. He has to mix two different ingredients together to get that 30% sodium iodine. I want you to look at the two different percents of sodium iodine that he's picking to mix together. And I'm going to lead to something. I'm going to point to this that Kristen is showing right here. That is what he needs, but he doesn't have it. But he can make it, because on the shelf in his lab, he has a 10% sodium iodine solution. Now let me just make this comment. He has a 10%. People, 10% is smaller than his target. He's got some 10%. And he also has some 60%. 60% is higher than his target. Rule, which you people should already know. If you mix a smaller strength of sodium iodine, 10 smaller than his target. If you mix a lower concentrate of sodium iodine with a higher strength of sodium iodine, 60 being higher than 30, 10 being lower than 30, if you mix a higher than 30 with a lower than 30, the 10% and the 60% can be tossed in the same container and stirred, and when it's stirred completely, it is conceivable and very possible that he can get the 30% sodium iodine that he wants. He can't get the 30 if he's going to mix a 10% with a 20, because both 10 and 20 are lower than its target. He can't get 30 if he's going to mix two lower ones, and he can't get 30 if he mixes two higher ones. You can't mix 60 with 70 to get 30. It's got to be a high with a low. That can get you the one in between. That's the mechanics of a mixture problem that we're going to be dealing with. I wanted to just point that out first. Now I'm going to bring this sheet down just a bit. The mixture problem is a chart problem as well. And we need to come up with some sort of a generalized formula that will help us do a mixture problem. And so here is a generalized formula, and then I'll point it out by sharing something in a realistic sense that my family and myself deal with. Here's the generalized formula. Column number 1 is going to be stated as amount of solution. The total amount of solution that is in the container. The label for the total amount of solution would very likely maybe be liters, milliliters, quarts, gallons, something on that particular order. The second titled column is the percent of the particular type of ingredient that the word problem is talking about. Now, when we actually do problem number 4 in a moment, the ingredient that we're going to be dealing with is going to be sodium iodine. That's the ingredient that the chemist is going to need to contribute to the vaccine. If we take the total amount of solution that is in the container and we multiply that total amount, by the percent of the ingredient of whatever you are talking about, the answer that you will get after you multiply will be another amount. It'll be an amount that is oftentimes called a percentage. It's the amount of whatever the ingredient is in its purest sense. It will give you the amount of nothing but that pure ingredient. Now I'm going to relate something here as I pull away just for a moment. We in our family, we drink quite a bit of the Simply products. And one thing that we drink quite a bit of is the Simply Blueberry Lemonade. Blueberries, good for you. Keeps a lot of things away from you. When the lid is on this, the total amount of liquid that is in this container is 52 fluid ounces. When you buy it off of the shelf at Vaughn's, it's 52 fluid ounces. When you turn that container around, you're not going to be able to read it, and I don't care that you're able to read it. Up here on the top, it says that the strength of blueberry juice that is in this entire container is 11%. 11% expressed as a decimal, move it 2 to the left, 0.11. People, if I take the total number of fluid ounces of liquid that is in this container, no, it's not all blueberry. It's got lemons in it. It's got other natural additives. If we multiply the total fluid ounces of solution that's in this container, and we multiply it by the strength of the blueberry juice that's in here, 0.11 times 52. Here's the multiplication. I multiplied, I came down and I moved the decimal point over twice. Almost 6 fluid ounces of this entire container, almost 6, 5.72 fluid ounces, almost 6 fluid ounces is nothing but pure blueberry juice. Pure blueberry. Why blueberry? Because this was the strength. This was the percent of strength of the blueberry juice in that total. This is a generalized formula that we use to do a mixture problem. Now, before I leave this and pull this sheet out of the way, this is going to be a key aspect when we set up our chart. Don't worry about what's going to go in there. This little chart is up here to point this out. When you identify the titles of your rows, one thing you're not going to see in the mixture problem, you're not going to see the word total written here. But what will be written here when it's written down, it really is going to represent a total. But the word total is not going to be written there. Because here's what has to be done on a mixture. 2 different strengths have to be mixed together. The lowest percent has got to get mixed with the highest. I don't know if you can recall those percentages that I just read on the sodium iodine. We're going to mix a 10%, the chemist is. That's low. He's going to mix it with a 60%. That's high. And what he wants at the end, he wants his targeted percent at the end. So when the chart gets filled out, we're always going to let row 1 of the mixture problem be the lowest percent. We'll always let the middle column be the highest. And the last column will be the percent that is desired. The percent that is desired. And people, the percent that will be desired will always be a percent that is found in between the low and the high. This was 10. This is 60. And this is 30. I believe if I've got my percents, yeah. He's 10, he's 60, and he'll be 30. You're not going to see a word total, but it's going to mean the same thing. Now, we're going to come over here and we're going to do it. I'm doing this number 4. We've already read it. You can, where is it?
Sir.
There it is.
Yeah.
Let's erase.
Okay.
Good Lord didn't give us enough hands. All right. Number 4. Step 1. How many milliliters of the 10% solution and of the 60% solution should be mixed? You just write this. This is good enough. Abbreviate milliliters. Milliliters of 10% and 60. That's what we need. There's the low. There's the high. You got to mix low and high to get the target. So that's what we're asking for. That's like roses and carnations. That's like adults and that's like children. That's like the 9% investment, that's like the 11%. It's 10% and 60% that we're going to need. Step 2, make the chart. The chart will have 3 columns. And we're going to title those columns pretty much in the same way as we did that, simply blueberry lemonade. Column 1, we can just write this. Amount of solution multiplied by, middle column, I believe over there it said percent of ingredient. But now we know our ingredient, sodium iodine. Percent of sodium iodine is equal to amount of pure, that's the key word, amount of pure sodium iodine. 3 rows. Okay. Row number 1, the lowest percent. He's going to have to take some 10%. That's the lowest. He's going to have to mix it with the highest. See, these are the 2 unknowns. They're going to be the letters. Down here, not the word total, but a word that means the same thing as total. In this case, it's going to be the desired percent that the chemist is going to need. He needs a 30% at the end. What amount of solution is going to come from the 10%? We don't know. They're asking us to find that. We'll give it an X. How about the amount in the 60%? We don't know that. We'll give it a Y. But we do know how many milliliters of sodium iodine that the chemist is going to need at 30%. Back over here, he needs to obtain 50 milliliters of a 30%. So we know that total, he needs 50. Roses, carnations, 20. Adult, children, 800, etc. There's equation 1. Now let's move over here. This column, the percent strength of the various sodium iodines that he's drawn from. He's going to take some 10% sodium iodine. We need to express that 10% as a decimal. 2 to the left. You need to express this, 2 to the left. And you need to express his desired strength that he wants at the end, 2 to the left. Now I'm going to keep those zeros on there. You could take them off, but I'm going to keep them on there. Now just like we did with that blueberry juice. If we want to find the number of milliliters of nothing but pure sodium iodine from this first container that he's drawing from. He's drawing initially from a 10% labeled sodium iodine. If we take the amount of solution and multiply it by the strength of the sodium iodine that's in that solution, 0.10 times X will give us this. That might look like just any ordinary algebraic expression, but what that stands for is this. It stands for nothing but pure milliliters of sodium iodine. That's nothing but pure sodium iodine. But he's going to take some sodium iodine from this other container labeled 60%. If we take the amount of that solution Y and multiply it by 0.60, 0.60Y is going to give us more pure sodium iodine. This is the same pure sodium iodine here that it is there. Same, it's the same fluid. And then finally the last row. If we take the total amount of solution, 50 milliliters is what he needs at the end. And he wants that 50 milliliters at the end to be at this strength. If we multiplied the 50 by the strength that he wants that 50 to be, just write it like this first. 0.30 times 50. And then, people, I'm going to do this to save a little bit of time. We're going to multiply right now that 50 times that 0.30. 0, 0, placeholder, 0, 15, 1500. You're going to have to move that decimal point over twice. Just write the word or, and right in here, just put 15. That 15 came from multiplying those two. Okay. All right. Now, I probably shouldn't have done that move right away, but I'll correct myself when I get over there. Let's go to the system. Equation number 1, column 1. Equation number 2. I kind of multiplied too quick, but I'm going to straighten this thing out. That's in hundreds, that's in hundreds, and that's in hundreds. I'm going to move them. Twice to the right, twice to the right, twice to the right. We get a 10x there. We have a 60y. People, I want you to forget this that I did. I wasn't wrong, but I just want an alternative. Just forget that. When we multiply 30 times 15, that's going to give us 1500. So ignore that 15 that I got right there. Just ignore that. Pretend that you didn't hear it. Just pretend that you saw the move that I did. Now let's write this brand new equation. 10x plus 60y is equal to the result of multiplying 30 times 50, 1500. There's the system. Now I'll go back and I'll use substitution. I'm going to take that top equation and pull it off. Just to be different, I'll solve it for y. Get rid of that x, subtract it from both. Now let's substitute. 50 minus x is the value of y. We're going to put it right in place of y in this second equation. Down. Plus 60 times the value of y. The value of y is 50 minus x, and that's going to be equal to 1500. 10x plus, distribute, 60 times 50. Well, 6 times 5 is 30. Add on 2 zeros. Negative 60x is equal to 1500. Combine like terms. Positive 10x coupled with a negative 60. Negative 50x plus 3000 is equal to 1500. Negative 3000. Negative 3000. We'll get a negative 50x is equal to a negative 1500 over negative 50 over negative 50. X is equal to, cancel out the ending zeros, 150 divided by 5 should give us 30. Here's one of our answers. 30 milliliters of X. X is 10%. You label that as 10. So the chemist is going to need 30 milliliters of the 10. Now to get the Y, let's substitute 30 in place of X there. and the chemist is going to need 20 milliliters of the 60%. So those are the two different amounts that he's going to need. Okay? Okay on timer?
Out of data.
I think we'll stop it. Yeah. I think we'll go ahead and stop. Got to be a little bit careful with the time going on with this machine that I've got, so I'm going to call it a quits tonight. I'll be sending an email to you, and I'll re-instruct some things. We'll do a second mixture problem tomorrow along with the distance problem and take care of it. Just takes a little bit of time to discuss. I appreciate your time, and we'll reunite tomorrow. Okay? Have a good night. Bye-bye.